Hi everyone, today we are going to be converting fractions to decimals for a quick decimals review. Before we get into converting, I do want to point something out. 4 divided by 2. What's another way I can write this division problem instead of using this symbol here? Well, I can write it as a fraction. A fraction is a form of dividing. You put the dividend, the number that's being divided, on top, and the divisor, the number that's doing the dividing, on bottom. Same here, and same here. Dividend, divisor. Now, I can reduce this fraction, right? If you need help reducing, I do have a video in the fractions review playlist. I'm not dividing by 4, I'm dividing by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. 2 over 1 is just written as 2. We also know that 4 divided by 2 is 2, so I kind of just proved the fact that a division problem can also be written as a fraction. We'll do the same thing here. 2 over 2, I can divide by 2, and I get 1 over 1, which is just 1. 2 divided by 2 is 1. 1 over 3 can be written as 1 divided by 3 can be written as 1 over 3. Now let's actually do the process here. So we said that the top was the dividend, the number that's being divided. The bottom is the divisor, the one that is dividing. So I'm going to write this real quick as a decimal. I'm going to bring my decimal up. In order to convert fractions into decimals, you have to really understand how to divide by decimals, and I do have a video up about that if you want a more descriptive understanding of how to do this. It's in my decimal playlist. 4 goes into 3, can't happen. 4 goes into 30, can't happen, and it goes in 7 times. 4 times 7 is 28. Subtract the 2, and I get 2. I still have a remainder, so I'm going to add another 0. 4 goes into 20 5 times. 4 times 5, 20. Subtract the 2, I no longer have a remainder. I don't have any other numbers to bring down, so I know that I'm done dividing. 3/4, 0.75. This is a fraction that you should automatically know how to convert. It should be an automatic memorization, okay? One way that I remember is 3/4 of a dollar. 3/4 is 75 cents. Same thing for 1/2. 1/2 is a problem that you should definitely memorize when it comes to converting. 2 into 1.0. 2 into 1 cannot happen, but 2 into 10 can, and it's 5. And I know that 2 times 5 is 10, so I won't have a remainder, and I won't have any other numbers to bring down, so I know I'm done. And I also know that half of a dollar is 50 cents. Remember, we always have an invisible zero, however many zeros we want, after the last number in our decimal. 1/4 is another one that we should memorize. 4 into 1.0. 4 goes into 1, cannot happen. Bring up my decimal. 4 into 10, 2 times. 4 times 2, 8. 2 left over. Bring down the 0. 4 goes into 20, 5 times 4 times 5, 20. No longer have a remainder, no other numbers to bring down. Also, I know that a quarter of a dollar or 1/4 of a dollar is 25 cents. So definitely memorize these 3 conversions. They happen often in the real world. These 2 problems here are not quite as easy to convert, but if you understand the process, then you should be good. 9 into 1.0. 9 into 1 cannot happen. 9 into 10, 1 time. 9 times 1, 9. Subtract the 2, 1 left over. Bring down the 0. 9 into 10, 1 time. What is 9 times 1? 9. Subtract the 2, 1 left over. Bring down the 0. Look, the process is repeating, and it's going to continue to repeat for an infinite amount of times, okay? I forgot to bring my decimal up. So 1 out of 9 can just be written as 0.1 with the bar on top, which means repeating. So if I ever see a number with a bar on top, that just means, it's not a highlighter, that just means that that number is going to repeat itself an infinite amount of times. Let's try this one. 9 into 7.0. How many times does 9 go into 7? Well, it can't. 9 into 70 can happen, and it's 7 times because 9 times 7 is 63. Subtract, and I get a remainder of 0. And I need to bring, that looks like a 6. Bring down my 0. 9 into 70, 7 times, 9 times 7, 63. This one is also repeating. Add another 0 to bring down. I'm seeing a pattern. It's going to repeat over and over and over again an infinite amount of times. So I'm just going to write this as 0.7 with the bar on top to show that I have a repeating decimal. Okay? And that's that.